Recording in progress.
So in Algebra 2, we did a review guide covering sections 3.3 and 3.4. I'm going to leave these up, the ones that we did in class. I'm going to leave them up for just a second so you can pause the video and get those copied down. This is section 3.3. At least the first one is. The second one's 3.4. Actually, no, both of them are section 3.3. That was just a typo. Anyway, so for anybody who was not in class on Thursday, you can pause this and get these to kind of fill them in and see the process there. So that's the first one. You can see I wrote my two equations. X is the first number, Y is the second number. Two numbers whose sum is 180 is X plus Y equals 180. And two numbers whose difference is 18. Make sure the X and Y are in the same order. X minus Y is 18. So I did that, got rid of the Y, solved for X, and then plugged that X in to figure out what the Y was. All right, so for number 2, let's zoom out just a little bit. This is oh my goodness. Okay, there we go. And you might want to do these on a separate sheet of paper. I forgot to space it out a little bit so you had a little bit more room. This is one of those where we have a 2-digit number. So first thing we have to do, whenever you have a 2-digit number, you represent the 2-digit numbers. It's 10 times whatever number's in the tens place. So we make that X plus whatever number's in the Y place. So if you remember from our notes, the example was 23. The 2 is in the 20, and the Y would be the 3. So for 23. All right. And then the reverse of that, you simply reverse your X and Y. You put the digit that was in the ones place in the tens place, and vice versa. All right. Then we also just need to kind of make sure, I sort of did this backwards. The number in the tens digit is represented with the X, and the number in the ones digit is represented by the Y. Okay, so then we're asked in the problem to find the sum of the digits of a 2-digit number if it equals 12. That's where the X plus Y equals 12 comes from. And then the second equation we're asked to create is when the digits are reversed, the new number, aka the reverse number, is 18 less than the original number. So that's where we go back to these guys right here. And blah, blah. Okay, here we go. We create the equation. Whoops. Let's see if I can get this select. Okay, let me zoom in a little bit. That you have here in blue. So what it says is that the reversed number, 10 times Y plus X, is equal to the original number, 10 times X plus Y, but less 18, so minus 18. And then you can see in red here, I have reduced my equation in order to combine like terms across the equal sign. So I moved the Y and the 10X from the right over to the left, and I got 10 minus Y. 10Y minus Y is 9Y. X minus 10X gives me negative 9X. And then you just bring down that negative 18. And then all of these are multiples of 9. So I just divided everything by 9 to get a simplified equation. Y minus X equals negative 2. So then we go over here to this little guy. I took the X plus Y, and you can see I flipped the X and Y, which you can do. That's our commutative property of addition. So I took my simplified Y minus X equals negative 2, and then I put under it I flipped my X and Y plus X equals 12. And you can see here, this allows me to eliminate one of my variables. Yeah. And so I end up with Y plus Y, because we're adding these together. That gives me 2Y. And then negative 2 plus 12, same as 12 minus 2, that gives me 10. So then I'm able to solve for Y. Y equals 5. Once you know your Y, it's very quick. I just plugged it into the X plus Y equals 12. So Y is 5. X plus 5 equals 12. Subtract 5 from both sides, and I get the X is 7. Now, we have to go back and put those together to create our original number, which is what we're asked to find. The X went in the tens place, so that's your 7. And the 5 went in the Y's place, in the ones place. So you end up with the number 75. And that's it. I didn't mean to spend this much time, but I did. All right. For this one, I am going to give you just pause the video, The first part of this asks you to use two variables to write out a table. I'll let y'all read the problem and see what I've done here. Then in the second part, we went ahead and wrote our equations and solved it. So like I've said before, when we do these, typically with an interest problem, we have a principal equation and we have an interest equation. So that's what you have here. The x plus y equals 150,000. That's what the guy invested. The interest equation takes the interest we got from our table. And in this part of the problem, they told us that his total annual interest that he earned was $9,900. So that's where that came from. Then I took my first equation over here and created a substitution where I had y equals 150,000 minus x, and I plugged that into my interest equation, and then I simplified and solved for x. So that's where we determined that x is equal to $70,000. So he invested $70,000 at 7%. Once I determine that, it's just his total principal, 150,000 minus 70,000, means that he invested the rest of it, 80,000, into the account that was earning 6.25 interest. There's our answer. Let's see. I let everybody do that on their own, so we'll do that together. What else did we do? I guess that's all we did. Okay, so let me go ahead and spend the rest of this video working through the rest of these. Number one for graphing systems of equalities is the process we use to test our graphs. So that's what we use to figure out which side of the line or absolute value, what side of the graph we highlight, which I know some people found some confusion with. So hopefully this will help. All right, so all we do is we take the point given. Let me make this. Okay, just in case. All right, we just take the -4 is our x value and the 1 is our y. Remember, the ordered pairs are always in the order x, y. So all I have to do is I have my two inequalities, and I'm going to plug those in and see if I get true statements. If the x and y, when I plug them in, give me true statements for both equations, it has to be both, that it's true, then yes, this point is a solution for the system of inequalities. If it is untrue or gives a false statement for one of the equations, you have no solution. Okay, so start off with the first one. I have 6x plus 9y is greater than or equal to -20. So I'm going to plug in the -4 for the x, 1 for the y, and it's supposed to be 20, lost too. Okay, 6 times -4 is -24 plus 9, 20. -24 plus 9 gives me -15. Now be careful, when they're negative, when both numbers are negative, the smaller number is actually a greater value because it's higher, more to the right on the number line. So this is a true statement. So I'm going to put yes. This one is true. -15 is greater than or equal to -20. Let's do the other one. The other one is x minus 2y is less than or equal to -15. So x is -4 minus 2 times 1, 15. So -4 minus 2 gives me -6. -6, because they're negative, smaller number, so it's farther to the right than -15. So -6 is not smaller than -15. This is a no. So as long as one of them is a no, the whole thing is a no. Excuse me. This ordered pair is not a solution for the entire system. All right, so let's try with the other one. Again, my x is 9, my y is 4. So y is less than 7 times x plus 13. Y is 4. 7 times, definitely going to be true. This is a big number. 4 is definitely going to be 4. Even if my x was 0, this would be true. 4 is still less than 13, so we know it's going to be true, but this is 63 plus 13. 4 is definitely less than whatever this is, 70, 76. So this is a yes. Let's check the other one. Y is greater than negative x plus 8. Y is 4, 9. So negative 9 plus 8 is negative 1. 4 is definitely greater than negative 1. So yes, this one is true because both of them are true. The whole thing is true. So yes, this ordered pair is a solution for the entire system of inequalities. Okay. You can see here I've already given you the formula that we used before for absolute value systems of equality. You don't have to worry about slope and y-intercept and finding all of your different points when you have an absolute value. Remember, absolute value problems are always, you've got the vertex, and then the graph always goes at a 1-to-1 ratio, at least with the ones we're working with right now, up. So it makes kind of a V. So what we have to do here is we take the absolute value that we're given and we have to make it fit into this formula. So I'm going to take what I have, y is greater than or equal to the absolute value of x. And here's where you have to be really, really careful. You have to keep the subtraction in the formula, but it needs to match plus 1. So that's how we know that in this case, the h is a negative 1 because two negatives make a positive. So you have to keep the subtraction, but you also have to make it mean the same thing as x plus 1. So that's why we make our h negative 1. Now h is the x coordinate of our vertex, so that means my h is negative 1. So I already know where I'm going to go left and right to find my vertex. Now, in the other case, the plus k, it has to be the same value as minus 3. So in order, again, we go back to our definition of subtraction. Subtraction is simply adding a negative number. So we're adding the opposite. So that means that my k is negative 3. This has the same value as y is greater than or equal to x plus 1 minus 3, which is what I have in my system of equations here. So that means that my k is negative 3. So I'm going to go ahead and graph that. I've got my vertex, so let's find that point. Negative 1, negative 3 means I go left 1 and down 1, 2, 3. So here's my vertex. The rest of it is just drawing, connect the corners. It's always a 1, at least at this point. It's always a 1-to-1. I don't know how great I am at drawing straight lines. There I go. At the end. It's the same thing on the other side. I'm not going to be able to do this. Ooh, there we go. All right, and there's the other one. Now I have to figure out which side of this graph that I just made am I going to highlight? Which part is my solution set? So I'm going to use the origin because it's nice and it's obviously not on the line, it's above it. So if I plug in the origin, this goes back to the problem we just did earlier where we plug in a test. So, oof, excuse me. We plug in my test ordered pair of the origin 0, 0 into my absolute value. So how much room do I have? I have enough room. We can do this. So I'm going to plug that 0, 0 over here. So y greater than or equal to, well, sorry, y is 0. Plug in the 0 for the y. Plug in the 0 for the x. And I get 0 is greater than or equal to, the absolute value of 0 plus 1 is 1 minus 3. 0 greater than or equal to 1 minus 3 is negative 2. Well, yep, that's true. So because I got a true statement, that means that the side of my absolute value graph that includes the origin is my solution set. That's the side I'm going to highlight. So let me go ahead and do that. That's mashing. I know one of y'all is running that meme through your head right now. Okay. All right, so I'm going to highlight the part that includes the origin since it gave me a true statement. Okay, so now let's go to the other. Now here we have our linear equation. So this one, the formula for the linear equation is that slope intercept. I'm trying to get my cursor to move. There we go. Okay, so this one's already in slope intercept form. You can think of it as this is like your y is less than or equal to mx plus b. And m is your slope. You can also write positive 1/2 as negative 1 over negative 2 because we have two negatives. That makes it positive. So that's going to tell us we're going to go up or down 1 and left or right 2. Remember, the numerator is the change in y. It's so messy. I'm so bad at this. Change in y over the change in x. So top is up or down. Bottom denominator is left and right. Okay, moving on. And our y-intercept, go back to your problem there, the y-intercept is at 2. So it's at 0.02. Remember, y-intercept is a point. So that's your starting point. You start at your b, your y-intercept. So let's go to our graph. I'm going to start at my y-intercept, which was that positive 2? Yes, positive 2. So my y-intercept means it's right here. Whoops. Right here. And my slope is positive 1/2. So it tells me if I go up 1, I have to go right 2. Or if I go down 1, I have to go left 2. So I'm going to kind of go in both directions since this is pretty close to the middle. So I go right, what did I say? Up 1, right 2, up 1, right 2, up 1, right 2. So here, and I'll get it there too. Or I go left, no, down 1, left 2, down 1, left 2. Okay, here's the thing. You'll notice as I draw this, it's looking a whole lot like a line, which is what we want it to, seeing as this is a linear equation. If you put a point on there that does not make a line, like say you accidentally put one like up here, check your math. All it means is that something went a little wonky and you just did some calculation wrong. It should always equal a line at this point because we're working with linear equations. So I'm going to go ahead and connect my dots. Are both of these? Yes, both of these are greater than or less than equal to, so that's why they're solid lines, not dashed. Let's check that. And there's my line. All right, so in this case, again, the origin is close, but it's not on the line. So I'm going to go ahead and use that same test point, the origin, to test my line to see which side of it I'm going to highlight. I have enough room underneath, so I'm going to do it here as well. So again, I'm going to use 0, 0. I don't have to use the same point. Just want to clarify that. I am because it's convenient. Okay, so my equation is y is less than or equal to 1/2 x plus 2. And so I plug in the 0 for the y and the x. 1/2 0 plus 2. Well, the 1/2 anything times 0 is 0. So that disappears. I end up with 0 is less than 2. So in this case, again, I have a true statement. So that means that the side of my line that includes the origin is the side I'm going to highlight. Now, at this point for you guys, when you highlight it, you know it's that side that's less than my purple line. So all you have to do is highlight that middle triangle. I'm going to highlight the whole side just to kind of show you where the solution set is. And because when I do it with a highlighter, it obviously changes the color of our solution set. And so it makes it still pretty obvious. In this case, it's kind of a green. So, but for you guys, that middle part where mine is green, that's where you would want to make your highlight significantly darker because that is the section that is your solution. When you do the other highlights, I've seen a lot of you do like the whole thing really, really dark. Use the side of your pencil and just very lightly gray it out. That way, when you highlight the solution set, in this case, the little triangle in the middle, it's very obviously different what your solution set is. The rest of that is unnecessary. That is not a solution. That's a section that's true for one, but not the other. Okay, let's go and move on to the next one. All right, so in the next case, we have two linear equations. I don't have any absolute value, so I'm going to have to change both of these to slope-intercept form so that I can graph them. I'm going to start with the first one. 3x plus 8y is greater than 24. So obviously, if we're putting it in slope-intercept, this is our y equals mx plus b. Obviously, we are not going to be using an equal sign here, but you're solving for y. You want to get your y by itself. Subtract the 3x. I get 8y is greater than negative 3x plus 24. And then when we divide everything by 8, y is greater than negative 3 over 8, which is fine. That's our slope. We need a nice fraction anyway. Plus, 8 does go evenly into 24, and that gives me a y-intercept of 3. I got enough room. Okay, so let's go ahead and define these. So my slope is negative 3 over x, or 3 over negative x. If it's negative, just make sure the numerator or the denominator is negative, not both. And then the y-intercept is positive 3, so it's at 0.03. Again, I use my y-intercept to start. And in this case, both of these are not equal to, they're only greater than. So you're going to want to make sure when you do draw your line that it's a dashed line. Let's go ahead and go over here. Let's start at the origin to find our y-intercept. This one's going to go up 3. So there's my y-intercept. My slope tells me where to go from there. The negative 3 tells me I'm going to go down 3. And then I'm going to go right 8. So right here. And I'm going to go the other direction. I'm going to go up 3. 1, 2, 3, and then left 8. 1, 2. All right. And as you can see, when you connect the dots, you're going to get a decent. If we did it perfectly with a ruler, it would be a nice straight line. That's close enough. And it's supposed to be dashed. Darn it. Do that every time. I do find dash actually is probably easier for me to make it look a little straighter though, so I'm not super mad. There we go. So dashed line. All right, let's go do the other one. Then we'll test them. Excuse me. Okay, so the other one is 5x minus 4y is greater than negative 20. So I'm going to move my 5x. I get negative 4y. Don't forget to keep the subtraction as a negative with 4. It's greater than negative 5x minus 20. I'm going to divide everything by negative 4. Negative y. It's negative, so I have to flip my inequality. So now it's less than 5 over 4 x, and 4 goes into 20. They're both negative, so this becomes a positive 5. All right. And I'm just going to denote that. That's what I use to make my graph. So let's do the same thing here. My slope, you can see here it's negative 5 over negative 4, or it's 5 over 4. You might use both. And my y-intercept is positive 5. So ordered pairs are, 0, 5. Now that I have that, I can graph it. Also, I know it's less than, not equal to, so I'm going to try to remember to make it dashed the first time. All right, so first we start with our y-intercept. So go to the origin. Y-intercept is 5, so I'm going to go up 1, 2, 3, 4, 5. And then my slope, negative 5 over negative 4. I'm going to do that one first. So that means if I go down 5, 1, 2, 3, 4, 5. Wait, 5. I have to go left. right here. And then if I go up 5, 1, 2, 3, 4, 5, that's the very top. I have to go right 4, 1, 2, 3, 4. Which makes sense. We have a positive slope, so it should be going uphill. I'm also going to go, just to give myself another dot, down 1, 2, 3, 4, 5, left 1, 2, 3, right here. Okay, so now we can graph it. Like I remembered the first time. Okay, now we have to test it. So in this case, I'm going to use the origin again. Because why not? It's obviously below and a little bit to the left of, excuse me, it's below both lines and a little to the left of the pink line, a little to the right of the purple line. So it'll tell me if I get a true statement, then that bottom part is the part I'm going to highlight for both of these. If it gives me a false statement, that just means that I'm going to highlight the top. Okay, so test point is at 0, 0. So my first equation, 3x plus 8y is greater than 24. Excuse me. Okay, that means, well, that means 3 times x, or 3 times 0, plus 8 times 0, which is always just 0, is greater than 24. So instantly I see I've got a false statement. 0 plus 0 is still 0, and 0 is definitely not greater than 24. That was, in my case, the pink line. You might want to label yours if you want. Line 1, line 2, something like that. But that means that the side with the origin, is not a true statement. So I'm going to highlight, the other side. The side that does not include the origin. Okay. So that means that either the left side of that purple line or the right side of that top portion is going to be my solution set. So change my color to that, and then let's test the second equation. That was 5x minus 4y. 5x minus 4y is greater than negative 20. So it looks like this one's going to be a true because 5 times 0 minus 4 times 0 is just 0, and 0 is greater than a negative number. So this one is true. So it means the side that includes the origin is the side that I'm going to highlight, which means my solution for both of these is going to be this part, right? Because that's the part that's true for both. That's so messy. I can never get my corners. It drives me bonkers. All right, so I'll go ahead and highlight this just so you can see. So this is a valid solution set for the second inequality, but it is not true for the first. So that's why it's not going to be that darker color, but you can highlight it just to kind of show that we are, but it is true for one, even though it's not true for both. So our solution is this section right here. I should not have done that. Okay. So everybody's got that. If you have any questions about this, please talk to me about it tomorrow. I know we have a quiz tomorrow, but we can still kind of talk about it. I can help maybe try to explain it a different way or something. All right. Anyway, let's get to, is this the last one? Kind of almost. All right. This one, we did something like this yesterday when we did the homework for section 3.4. They've given us the graph. We have to write the system of equalities that represent it. So I'm going to start with, I'm going to call this my first, that's my first inequality. And then this super steep one here, that's going to be my second, just so I can keep track of them. All right, so first off, I'm going to find my y-intercept. Also, they're both lines, so they're both in the form of y equals, obviously it's not equals, it's greater than or less than, mx plus b. We'll figure that part out later. And so I need to find the y and the x stay. There's always going to be a y and an x. I need to find the m and the b, the slope and the y-intercept. I'm going to start with my y-intercept. It intersects the y-axis right here. So I know with my, it's going to be positive, so I can keep my plus sign. And I go to the origin, and then I see I go up 1, 2, 3. So that means that my y-intercept is 3. Now, from that y-intercept, I need to find another nice, neat point. It looks like I have one here. So what I need to look at is where do I go to get from my y-intercept to that point? And that's going to give me my slope. So for my slope, I want to do this. Okay, just let me give, I'm going to do it down here. Slope is the change in y over the change in x. So it's my change left to right, up, ugh, I did it again. The numerator is up and down, and the denominator is left and right. Now, if I start at my y-intercept, you can see that I go down 1. So that means my change in y is -1. And then my left and right, I'm going left. So that means I go left 1, 2, 3. And so my left, it's -3. Well, -1 over -3 is positive 1/3. So that means my slope is 1/3. And there's my, well, there's the beginning of my inequality. Now I have to figure out, I have to find a point and test it to see if it's greater than or less than. I know it's not equal to because both of these lines are dashed. Okay, so let's go ahead and do the second one. How to organize my steps. I'll just do it right beside it. This one, I'm going to use the same form. Y equals something x plus something. You know, keeping my base formula y equals mx plus b. But now I'm looking at the second line. So I need to find, I'm going to find my y-intercept first. I see that it's all the way, we're going to assume it's right here down at negative, what is that? 1, 2, 3, 4, 5, -5. So that means this is -5. Excuse me. And so now I just have to find my slope. So I have, from there, I have another nice neat point right here. So I'm going to do the same thing with my slope. I know that it's my change in y. So let's look at my change in y. My change in y is up 1, 2, 3. Put it in here. I know some of you all write bigger than I am, but I do. So I apologize. Try not to do it like I do if it makes it super messy. Just use some different paper. My change in y is up 3, so that's a positive 3. My change in x is, I went right 1, so that's a positive 1. Well, that's just 3. So my slope is 3. So the coefficient of x is 3. Okay, so now the only thing I need to do to finalize this is I need to figure out what that symbol is. I know it's not an equal sign. It's got to be a greater than or less than. So I'm going to take, again, I know some of y'all are like, can we pick a different point? But I'm going to go and use the origin. Because as you can see, the origin is dead center in the middle of my solution. So this shaded part, that's the solution. So I want to pick a point in that solution because then when I plug it in, whatever my answer is will tell me what my inequality sign is. So to test, I'm going to use the origin, 0, 0. And let's test my first one. Y equals 1/3 times x plus 3. Obviously, I know it's not equals, but we'll change that at the end. So y is 0. 0 equals 1/3 times 0 plus 3. Well, that just means that 0 equals 1/3 times 0 is just 0. So 0 equals 3. Now change that sign to make a true statement. 0 is less than 3. So that means that the inequality symbol for my first inequality is y is less than 1/3 x plus 3. Which makes sense because what part of that did we highlight? The part underneath it. Oh, whoops. I didn't mean to do that. Okay. We highlighted the part on the bottom, which so that makes sense that it's all the y values under that. But that's the final. So let's use the same test point for the other equation. So we're going to test the origin for y equals 3x minus 5. So we put in 0 equals 3 times 0 minus 5. Oops. And 0 minus 5 is negative 5. So 0, obviously 0 doesn't equal negative 5, but 0 is greater than negative 5. So that means that my symbol, my inequality symbol for the second one is y is greater than 3x minus 5. And now I have solved my system of equations. Those two are my system. All right, that's it. Go ahead and move on to the last one. This is one of the word problems that we had from the previous section, and I think all I'm asking you to do is write the system of equalities. You don't have to solve them. Judy's restaurant business exceeded its break-even point, and she now has a profit of $75,000 sitting in the bank. She needs to start a retirement fund and has found a stock portfolio that returns 5% annual interest, as well as bonds, which return 2.5% interest. She wants to keep $5,000 for emergencies, but would like her retirement fund to accrue $2,500 in interest each year. Write a system of inequalities that represent her investment strategy. Okay. So her total principal is $75,000. So that's our first inequality. We know that the amount that she puts into one, let's see, wait a minute, that's not true. She has a profit, hold on, profit of 75,000. But she wants to keep 5,000 for emergencies. So take out 5,000. So that means that her principal, total principal, is $70,000. So that means that the amount she puts in the stock portfolio plus the amount that she puts in bonds, call that Y, needs to supposed to be an inequality. Write a system of inequalities that represents her investment strategy. Let me think. Profit of, I guess we'll just say those two maybe are less than or equal to 75,000. I don't know. Let me double check. My brain stopped working. Okay, so the only thing, the only way I could keep this as an inequality is I know that the amount, because she wants to keep 5,000 on hand, is that the combined amount she puts in just needs to be less. We're going to make it equal to less than or equal to 70,000. So I don't know, like maybe she takes out more than 5,000 or ends up needing it. So we'll keep it an inequality, but we'll keep it equal to, since that's how much she plans on putting in there. Then we have the second one. So the amount, we know that, let's see, she wants to start a retirement fund. Stock portfolio is 5% annual interest. So I'll have that be, so we'll say 0.05x. This is our interest equation, plus 0.025 times y. She wants the amount she gets back to be at least 250,000 in interest. So that means she does not want to accrue less than 2,500. Sorry, making up numbers now. But it would be great if it was more. So this is definitely going to be a greater than or equal to the 2,000 that she ends. So that is the system of inequalities that we want. And that's all I asked for you to do, is to be able to interpret. And again, I feel like that's kind of the hardest part. Interpret the question into the system of inequalities. All right, I don't think I skipped anything. Let me just go back and double check. This is everything. Oh, yeah, covers everything. Again, if you have any questions, jot them down on your review guide and make sure you bring them to me before the quiz tomorrow. Otherwise, you'll have a great night. Thank you.